Hello everyone and welcome to another episode of Interstigation. In today's episode of Interstigation, we will go over the cosine limit. So, as I've gone over in the last episode, the sine limit, which wants to find the limit of this, and in that episode we've showed that this limit would be equal to 1. And there's nothing to know about other than that, so there's no daily problem for today. So let's get straight into the cosine limit. The cosine limit is the limit as sine x, similar to the limit as sine x over x, which it wants the limit as x also approaches 0 of 1 minus the cosine of x over x. If you notice over here, if x approaches 0, then this both numerator and denominator would approach 0, meaning that this would actually be 0 and 0 undetermined form. And in that case, we can have this 1 minus cosine of x, and we try to do some limit operations. So 1 minus cosine of x, how can we manipulate it? Well, we can try to multiply by something, because 1 minus cosine x over here, it kind of looks like half of a difference of squares. So we can multiply top and bottom to get 1 plus cosine of x, 1 plus cosine of x. And if we do that, then we can have this is just simply equal to, we can do the difference of squares to get that this is the limit as x approaches 0 of this 1 minus cosine squared of x using difference of squares, and the denominator is still x plus x times 1 plus cosine of x. And this using the so-called Pythagoras identity, but which is basically Pythagorean theorem. You can see it on the unit circle, and that would be x approaches 0 of sine squared x over x times 1 plus cosine of x, and that would turn into this sine squared of x, this same thing, but we can separate these into sine x and sine x. So that would be this sine x over x multiplied by the same limit as x approaches 0 of another sine of x over 1 plus cosine of x. So this times this is equal to this. And if we want to find the value of that, we've showed that yesterday that this is just equal to 1. So this is equal to 1, and we just are left with limit as x approaches 0 of sine x over 1 plus cosine of x. And we want to find that. However, if you notice that over here, this is not an undetermined form, because sine x is just equal to 0, and cosine x as x approaches 0, so just think of it as x equal to 0, so that's just 1 plus 1, so that would just equal to 0 over 2 as limit approaches 0. And if we have that, that's just gonna be equal to 0. So now we have our identity, so this is equal to 0. And let's try to visualize this on a graph. We have the cosine graph over here. So if we have the cosine graph looking like this, so 1 minus cosine of x, so it's just 1 minus this graph. If we have 1 minus this graph, so that would be something like this. Because if you think about it, something like if we have 1 minus 0, that's just going to be 1. So let's think about this. So this is the complementary part. So if this is equal to 0, then 1 minus 1 is equal to 0. When this is that, this is that. This is basically kind of like this. So if we have this looking like this, so like that, kind of like a reflection, and it's easy to see that this slope is equal to this slope. We've basically proved that the derivative of cosine of x at 0, so the derivative of cosine of x when x is equal to 0 is 0. So now we know that the sine is equal to 1, the cosine is equal to 0. And in the following episodes, I will finally go over the sine derivative and the cosine derivatives using these two identities. Thank you for watching this episode of Investigation, and I will see you in the next one. Peace out.